Today we're going to learn how to add and subtract fractions. So to begin with, we're going to look at fractions that have the same denominator. So if we look at the examples here, in our first one we've got 1/5 plus 2/5. So if the denominators are the same, in this case both 5, then we don't need to worry about doing anything other than adding those two fractions together. So underneath in diagram A is the solution. 1/5 means that we break our shape into 5 parts and we shade one of those parts. 2/5 means again we break it into 5 parts and we shade 2 of those fifths. So if we're adding 1/5 plus 2/5, it makes sense that we end up with 3/5 altogether. So 1/5 plus 2/5 is 3/5. On to B. B is a subtract question, but we set it out the same way. So both are in tenths, so both of our diagrams here and here have been split into tenths. The first one is 7/10, so we've shaded 7 pieces. The second one is 5/10, so we've shaded 5 pieces. Now if we started with 7 pieces and we're taking away 5 pieces, it means that we'll have 2 pieces left. So therefore it's 2/10. Now 2/10, that fraction can be simplified because both 2 and 10 divide by 2. So if you can simplify it, dividing 2 by 2 gives me 1, dividing 10 by 2 gives me 5. Okay, so the thing to remember there is that when you're adding and subtracting fractions with the same denominator, you just need to either add the top numbers, the numerators, or subtract, depending on what operation is given. Then we move on to fractions with different denominators. So this involves a little bit more work. We're going to look at the example 2/3 plus 4/7. So below I've got 2 rectangles drawn up. The first one I'm going to make represent thirds. And you can see that I've drawn the rectangle so that there are 3 rows of squares. I've also drawn the rectangle so that even though there's 3 going, so 3 rows across, if I look at the top here, there's 7 if I was to go down in columns. Right, and I've picked those 2 numbers because that's what my denominators were up here. And that's going to allow me to have what we call a common denominator. So we need a common denominator before we can add or subtract fractions. To get our common denominator, we look at our denominators and we multiply them. So our common denominator here is going to be 21. And if you think about a rectangle, and if your rectangle is 3 by 7, that means that there's going to be 21 small squares inside that rectangle. So that's our first step, find your common denominator. Now if we look at this diagram down here, I want to show 2/3. So what I need to do is look at each row represents 1/3. So if I want 2/3, I want to shade one whole row there and another whole row, and that represents 2/3. Now remembering that to add fractions I need common denominator. So 2/3 can also be written as something over 21. So within this rectangle there's 21 small squares. How many of them are shaded? If I count them up, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I've got 14 out of 21. And if you look carefully, that 3, to get 21, I timesed it by 7. So with fractions, you remember that you should do the same to the top as you do to the bottom. And that's how I get 14 if I didn't have my diagram. Alright, so that's the 2/3. Let's have a look at the second fraction. The second fraction is 4/7. So this time I need to look down at my columns because my columns, there's 7 of them. So if I shade my first column, that's 1/7. Second column is 2/7, 3/7, and 4/7. Let's now change that into a fraction that's out of 21. So if I count up all my squares there, I've got 3, 6, 9, 12 shaded. So 4/7 is equivalent to 12 on 21. If we were to do it without a diagram, which we will need to do later on, what did I do to the 7 to get 21? I times it by 3. What do I do to the 4 to get... So I must do the same to 4, sorry. So if I times that by 3, that's how I get the 12. Alright, so in this question we want to add. So if we're adding all those shaded sections together, in my first diagram I've got 14 pieces shaded. So I need to shade 14 again. So I'm going to just do the same shading as I did above. That's my 14. But from my second diagram I need to add 12. If I shade the top row, that gives me only 7 more. So I need to shade 12. So that's 7, 8, 9, 10, 11, 12. So my answer to the question 2/3 plus 4/7, if I count up all my squares here, I've got a total of 21 in my first big rectangle. 21 plus these 5 that I've counted here, so that's 26 out of my common denominator, 21. I can write that as an improper a mixed number, because at the moment it's improper. So as a mixed number, 21 goes into 26 once, and there's 5 left over. Okay, so that's how we add fractions when there's different denominators. And that's doing it by drawing some rectangles up, looking at the shaded parts, and then adding them together. That's one method, but obviously it's not always convenient to draw up the diagrams. So there's a quicker method that I'm going to teach you next.